This is the video going over the Chapter 12 multiple choice review. Okay, so for number 1, we have to decide which test it is. So we got to figure out how many samples and how many variables we're dealing with here. We have one sample, just the voters, and they're being measured on 2 variables. Do they approve or disapprove of the tax increase and highest level of education? So one sample, 2 variables is chi-squared test of independence. It would create a 2-way table, and on like the horizontal and the vertical would be the 2 variables. For 2 is about interpreting the p-value. So I'm including a sentence stem here that is general enough that it can be used not just for chi-squared, but any of the tests. So basically, assuming the HO is true, however you would phrase the HO being true, there is something chance, that's the p-value, of finding a value of whatever your cutoff is, or more extreme. And more extreme could mean bigger or smaller, depending on what direction your HA is going. So we're going to look for the phrase that has that sentence stem. And again, you need that first part, assuming the HO is true. Assuming that your sampling distribution can be centered around a HO, then we can talk about stuff. So assuming distribution of colors for the different types of candies is the same, that would mean this means HO is true. There is a 5% chance, so here's your p-value, of finding the test statistic of 12.59 or larger. So in this case, more extreme means bigger, because your HA must be a greater than situation. Okay. Well, and do I need to go over... this is the problem here with is different. That is not the HO. That would be the HA. Okay. So for number 3, I look at this and I instantly think we're goodness of fit because it's not a 2-way table. It's a list of given percentages and we're going to compare to them. And in general, for goodness of fit, the HO is that the given percentages, the given proportions are true. And the HA is that they're not true. And we have a sample that is going to be compared to those percentages. And it's either going to give evidence that the HO is not true, as in the sample is really different than the percentages we expected, or they'll be really close to those percentages, and then we failed to find evidence that the HO is not true. Okay, so here's your possible answers. Instead of like writing out a sentence, they wrote out a list since there were 5 of them. So the 5 proportions matching what they gave us in the table, that shows up in C here. It's the only one that has the correct HO. And then they said for their HA, at least one of the proportions is different, which is a way in a sentence to say all 5 of those proportions are not true. Well, let me say it different. It's not true that all 5 proportions are true. It's a weird way to say it, but it's kind of a way of, that's like the minimum requirement to make the HO not true, right? Like even if 4 of them were right, but one of them was wrong, that makes the HO wrong now because one piece of it is wrong. So it's one way to say at least one of the proportions is different. It's the minimum of what it takes to make the HO not true. This 0.2 is like the average of all the proportions. And I think what they're getting at there is if you were thinking it was a test for homogeneity and we're trying to say, well, if the HO is true, all the proportions should be the same and therefore they're 0.2. I think there's a train of logic you could go down there, but this is not a test for homogeneity because it's one sample compared to known percentages. Okay, so for number 4, you know it's goodness of fit because we have one sample and one variable, music genre, compared to given proportions. For 5, you have to do a little bit of algebra here. So we have a sample size of 39, so an N of 39. We know our expected counts need to be greater than or equal to 5 to, check off our conditions for chi-squared. So I just made a little equation. Equation count or expected counts is N times P. 39 is my N. I solve it, and I get that in order to fit our expected count condition, I need all of my proportions to be bigger than or equal to 0.128. So I just started looking through all my answers, and an E was the only one that had any that were too small. All of them were bigger than 0.128, except for these last two. So that makes E the one that does not work. And then for 6, so they're determining whether the toll booths are all used in equal proportions. So that's the HO. They're giving you the HO. Is that all toll booths are in equal proportions? We don't have a lot of, I guess you could go 1/8 of them. Each proportion would be 1/8, 1/8, because there's 8 total toll booths. But anyway, we saying they're all equal is the HO. The HA is that they're not used in equal proportions, or you could say at least one of the proportions is different. Another way to say it. Our p-value here is very low, so we definitely reject the HO. So we have convincing evidence of the HA, which is that they are not used in equal proportions. And that's it.